Okay, so in order to avoid the video being too long, I've gone ahead and stopped the video, and now I'm restarting to do problems 3 and 4. So for problem number 3, 3 and 4 are different kinds of problems where we have moles and molecules. So for problem number 3, I'm still starting, they all start the same with what I'm given as a fraction over 1. So for this one, I'm going to put 7.345 times 10 to the 15 molecule, MOLEC, remember, of C2H5 as a fraction over 1. Now the next thing I want to do is cancel those molecules down, MOLEC, C2H5, and I want to convert to moles, so I'm going to put mole on top. Now whenever I have molecules and moles in the same fraction, I want to use Avogadro's number, 6.022 times 10 to the 23rd molecules per mole. And so with mole, we get a 1, and with molecule, 6.022 times 10 to the 23rd equals. Now, before I get started with this, I want to estimate if I'm doing 7.345 times 10 to the 15 divided by 6.022 times 10 to the 23rd, in terms of my exponents, I'm expecting something along the lines of 15 minus 23, which is going to give me -8. So if I get an answer somewhere close to -8, -7, -9, I'm going to feel really confident about my ability to enter that into my calculator. So I'm going to put in 7.345 times 10, I use the EE button on my calculator, 15 equals, divided by 6.022, same button, EE, 23 equals, and I get this big number. Let's see what that is in scientific notation. Haha, to the -8. I feel great about that. My answer is 1.22. My deciding decimal here is a 9, which makes my 1 go up, times 10 to the -8 moles of C2H5. And we box that guy up because with all of this work on this paper, it's getting a little messy. That's always okay as long as you are showing your work. Okay, next question. If you are given 1.75 moles of carbon tetrachloride, how many molecules do you have? This is the reverse. So I start with 1.75 moles of carbon tetrachloride, CCl4, as a fraction over 1. My moles of CCl4 move to the bottom, and molecules, MOLEC, CCl4, go to the top. Now, I know moles and molecules. I'm going to use Avogadro's number. That plugs in with the molecules, 6.022 times 10 to the 23rd. I'm doing 10 to the 0 times 10 to the 23rd, which is really like 0 plus 23. So I'm expecting my answer to be somewhere times 10 to the 23rd-ish. So let's check and see. We'll plug it in. We get 1.75, enter, times 6.022 times 10 to the 23rd, enter, and I get 1.05 times 10 to the 24th. 1.05 times 10 to the 24th molecules of CCl4. And this feels like a really good answer to me because it's just a little bit more than 1 mole, and I know that 1 mole should be 6.022 times 10 to the 23rd. So if you double that, that'd be like 12. And here I'm getting like a 10 kind of answer. So I feel really good about the way that is answered.